do quite a few of them, as many as we can get done, because we don't have a whole lot of time, and I don't want to, 28? I don't want to waste all the time on this, because I want to move on to the next thing. Got OGT tests and park tests coming up, and we're way, way behind where we should be. 28, the Big Town football team outscored its opponents 5-2. Last season. If their opponents scored 38 points, how many points did the Big Town score? So opponents 38. Could we set up a proportion for that? What's your first ratio going to be? What'd they give you? 5-2, right? So 5-2. Whenever you're setting up any of these proportions, you just got to make sure you match everything up. The 5 is the points for who? Opponents or Big Town? Big Town. 2 is for the opponents. All right? So where's that 38 going to go in this other ratio over here? Bottom. Very good. What do we put on top? X. Now, all of you want to put X in there all the time. I would probably put something like B. Anytime you're doing a proportion, put in some other letter so it makes sense to you. When we get down to the bottom here, are we going to know what that B stands for? Yeah, it's going to be the points for Big Town. If you put an X in there, who knows, Keith probably think it means points for Xavier or something, right? Even though they didn't say nothing about Xavier in the problem. If I think I said it last time, start bringing a what? Calculator every single time. Every single time. So you should have your calculators out. If you don't have a calculator, you get a break today because I don't want to waste the time going around checking them. But do what? 190? And that equals what going the other way? Please don't forget, these are called your what? Anybody remember that? Starts with an E. Extremes. These are called your means. Extremes, first and fourth terms. Means, second and third terms. What do we do now? Divide by 2. Somebody help me out. What's 95? So how many points did the Big Town football team score? 95. Next question. Not a game. Says, what's it say, Tristan? Last season. Now, if it was basketball and you were playing defense, I just don't understand. I watch you out on the basketball court. How come you have none of that life when you come to my geometry class? If you don't know, who would know? Other questions? 34? The ratio of the measures of the sides of a triangle are 3 to 4 to 6. And remember, these are the sides. Now, I sort of lied to you because last time we had something like this. Did you put an X with each one of those? No. Remember, I told you, if you see something with this colon in it, you're always going to put an X with each one, right? Well, that didn't work for that one. Sometimes you got to do it setting up proportion. This one we could do setting up proportions, but it's easier if you just put an X with each one, all right? So instead of, if this is my triangle, instead of this side being 3, how long is it actually? 3x. 3x. How about this side? 4x? 6x. Do you have to draw that every time? All right? Once you understand how to do the problem, then just go from there. They tell us the perimeter is 104. What's perimeter mean? Distance all the way around it, right? So what equation could I set up? Equals 180, right?
No, 104.
104. Why not 180?
That's not the angle.
All right, not angles, it's sides. Chloe's looking at it and saying, well, that's ridiculous. I don't want to write all that, because we know she likes to complain, right? So could she have collected like terms before she did all that? 13x equals 104. Then what do you do? Good. 8. Is that our answer? What they ask us to find?
The measure of all sides.
Measure of the sides, right? So what do we got to do with that 8? Plug it in. So we plug in right here. What's 3 times 8? 24. That's one of the sides. What's 4 times 8? And then 6 times 8? I even helped Max out because look what I do out there, Max. Put 3 blanks out there so you knew that there'd be 3 answers. Next question. No others? 18. Tristan asked me after this one because I didn't hear you before I heard him. 18. 2 over 8 equals n plus 4 over n minus 4, right? It's supposed to be a minus there. First thing, you don't have to do this, but whenever I see a proportion like this, what do you think I do with that 2 over 8? I reduce it down. Because it becomes 1 over 4, is that going to make my multiplying easier? Yeah, you don't have to do it. But if you don't know your 8 facts, then it might be better off for you. Now the second thing, and I told you to do this every time, you see that you have a binomial in these two. What do you got to do to them? Put what around them? Put parentheses around them. Now we cross multiply. Normally I won't draw the bubbles. Did your teachers ever just draw the lines like that? Some of them do, some of them don't. Normally that's what I'll do because I'm too lazy to draw the bubbles. So we're going to cross multiply here. Well, 1 times that's just going to give you what? Just that, n minus 4, right? On the other side, multiplying the means here, you got 4 times n plus 4. And I highly suggest that you write it out that way each time, otherwise you're going to get confused. What do we got to do next? Distribute. Over here stays n minus 4. What do you get on the other side? 4n plus 16. Now what? Get all the variables on one side, right? Subtract the n. And if it helps you, put a 1 with it. Subtract 1 in. You're left with negative 4 equals, what's 4n minus 1n? Plus 16. Subtract 16. You'll notice too, as we're doing all these, the E-day, the white E-day, what did it cover? Proportions, right? It's the same stuff. Now what do you do? Divide by 3. Did I mess up somewhere? So 3 won't go into 20 though. Is that all right? Not in 3rd grade anymore, right? Everybody's in high school now. So can you come up with answers that aren't going to come out all nice and even? Yeah. Now, don't, and this is what I would not do. Are we dealing with fractions? Everything's in fractions, right? When you're doing proportions. Unless you start with decimals, which some of them do, like number 3 and number 6 and number 9, number 12, they got decimals in it. I would leave my answer as a fraction. So n equals, will that reduce any? No, so I just leave it, -20/3. The only thing you might do to it, if you wanted to change it to a mixed number, how many 3's are there in 20? You just told me by dividing it out, come on. 6. 6 times 3 is 18, 20 minus 18 leaves you, has how many left over then? 2. If you wanted to change it to the mixed number like that, that'd be all right. But you probably learned in algebra last year that usually you'd rather leave it as an improper fraction, right? Even though your 4th grade teacher probably told you, you can't leave anything ever that way. All right? My son is in 4th grade right now, and I tell him all the time he can't leave it that way because I know his 4th grade teacher didn't want it that way. Now, when he gets to algebra class, he's probably going to be confused, probably like you guys were, because that teacher's going to say, don't change that, leave it that way. And as soon as you see anything that's got a 6 in the denominator, a 3 in the denominator, a 7 in the denominator, should you grab your calculator right away? A 9 in the denominator? Because is it going to come out even? No. So you're better off to leave it this way because this is an exact answer. And what you guys were trying to give me was a rounded off answer. All right? Which is better, exact or rounded off? So just leave it that way. Plus, is it less work to leave it that way? Yeah, you didn't even have to grab your calculator. Next question. Which one, Tristan?
36.
Ratio of the measures of the sides, 7, 9 to 12. And the perimeter is 84. Somebody tell me the equation we can set up just from that.
7x plus 9x plus 12x equals 84.
Remember, you put an x with each one of these, right? Plus 12x equals 84. Again, you're dealing with the sides, not the angles, so it adds up to be whatever it is. If you add these two first, a lot of you do this. You try to add straight across, and it makes it harder.
28x.
What's that 9x and 12x give you? 21 plus another 7. Makes it easier sometimes when you switch around the order.
Divide by 28.
Divide by 28. What is it? 3. Is that our answer? Take that and you plug back into each of these. What's 7 times 3? 9 times 3? 27. 12 times 3? Those are our 3 answers. Those should add up to 180, right, Chloe?
Right.
No.
No, I don't know. I don't like that.
Sides of a triangle always add up to 180, right, Robert? I got him on that right before break, didn't I? Next question.
16.
Everybody got that one? Because I'm going to erase it. All right, watch closely on 16. Might do one more after this. That'll be about all. 16, I want to do it. Because this one here has stuff that you have to remember from algebra. First thing you're going to do on this, put parentheses around it. Put parentheses around those two binomials. Now when we cross multiply, when we multiply the extremes, the first and the fourth terms, it's 3x minus 1, x plus 2, leaving the parentheses around it. When I multiply the means, what do I get? What's 2 times negative 2? So that part we can do. With me to that point, Wade? This all look real familiar to you from Algebra 2, right? First thing you're gonna do once you get it to that point, FOIL. And this is, usually with these proportions, this is what confuses people the most. Because we want it in this form where it has two parentheses. So we want it in the form it's in right now. The bad thing is, you can't have that 4 over there. What's gotta be on that other side? 0. Alright? So you gotta have 0 over there. So we gotta get all this out of this form, move that 4 over, then try to put it back into that form. Okay? So for what we're gonna do with FOIL, multiply the first terms. What's 3x times x? 3x squared. Outer terms, 3x times 2, 6x, good. Inner terms, for the I there, negative 1x. Last terms, negative 1 times 2, negative 2. Now what we want to do, we want to move that negative 4 over, and we can do that first if you want. When you jump that negative 4 over the equal sign, what's it going to become on the other side? Positive 4. So if it helps you to just do this, rewrite all this stuff, we haven't even collected any like terms or anything. You jump that over and it becomes a plus 4. What's on that other side now?
0.
Now we collect like terms. 3x squared doesn't have any like terms for it. How about the 6x and the negative 1x? How come these two aren't like terms? One's squared and one's just a regular x. Negative 2, those are gone, that's gone. Positive 2 plus 2. With me to that point. Remember any of this from last year in algebra? Not really? Alright, next thing, and if you did the first E-Day, instead of going online, letting the people online do it for you, if you did the first E-Day, you'd have some idea how to do this. First thing you do, you find the factors of 3x squared. What times what will give you 3x squared? Well, what gave it to us up here? 3x times x. Is that the only thing that'll give you 3x squared? Yeah, that's it. So those are pretty easy. Those are the only two factors. So those are the ones we're probably going to use. Then you got to find the factors of the positive 2. What times what will give you positive 2? 1 and 2. Now is that the only thing? There's one more. Negative 1 times negative 2. Since all of these are positive, which one do you think over here we probably want to go with? Probably the positive ones, right? So what you do next, and anybody can do this, that's the first step. Draw the parentheses. Wade, even you can do that, right? Draw the parentheses. You come over here, you got to pick factors here and here, and that's what goes in these parentheses. The first ones go in these first spots in the parentheses. The one for the third ones go in these second spots in the parentheses, and we just got to decide how we're going to stick them in there. Well, 3x and x, is there a whole lot of choice which ones we're going to pick right here? No, you only got 2 of them, so we're going to put right here. 3x, we're going to put here. Now for the other ones, we said we're going to pick this one. There is a little bit of choice on this, because we could put 1 right here, 2 right there, or we could put what first? 2. The 2, then the 1. So we just got to make that decision, which way you want to go. You want to put the 1 first or the 2 first? This is why you guys didn't like factoring last year and why most of you don't remember it. Because now you got to check it. You like just getting the answer, and if we check it and it's wrong, what happens to most of you? You give up. You quit. Instead of going back and trying again, you just give up or quit. You know, crap, look at all this work I've done, now I got to try it all over again. Well, the way you check it Do FOIL again, except with FOIL this time. All you gotta check is the outer and the inner terms. And it should give us back what we started with right there. Outer terms, what's 3x times 2? 6x. Inner terms, what's 1 times x? What's 6x and 1x give you? 7x. Is that what we had in the middle to start with? It's not, is it?
So that'll be 3x plus 2.
So that means it's not right. So Levi's got the right idea. What do you do with it?
3x plus 2, and then x plus 1.
Turn them around. Let's see if that works. Outer terms, 3x times 1 is what?
3x,
2 times x.
2x, 5x.
Does that give you what we had right here? So that's the factored form. Factoring is like division, all right? So we started as a polynomial that looked like this, and we divided it up into something like this. And the reason we want it divided up that way is because now we have something that says this whole thing right here times this whole thing has to equal 0. Well, the only way that two things multiplied together can give you 0 is if one of them is what? 0. Anything times 0 gives you back 0, right? So what you're saying there is either 3x plus 2 equals 0 or x plus 1 equals 0. Let's solve that second one. What would make that 0? How would you solve it? Minus 1. So what's your answer?
X equals 0. What? X equals 0.
Couple of the bonus on the test that we did last time, right, or a while back, the one that you're supposed to redo, the bonus were just like this problem. You had to set them up and factor. How would you solve this one? Minus 2, good. 3x equals negative 2, then what? Divide by 3. What did we just say on the problem right before this one? You want to grab your calculator right now like David was getting ready to do? He stopped, didn't he? See, Max is still grabbing his. What do?
You just negative third.
Just leave it negative 2/3. Big boys and girls, you can handle fractions, right? So what's our two answers? Negative 1, negative 2/3. Sometimes this negative 2/3 won't work. Maybe this proportion here was something about the number of cows Farmer Brown has. Well, can he have negative 2/3 cows? No, he probably can't have negative 1 cows either, but that would make more sense than negative 2/3 of a cow, right? One more question. And a lot of times, especially on the geometry stuff, you might plug it back in and check, see if it works. If you're dealing with angles or segments, plug it in to see, because can you have negative lengths? Tristan, can this room be a negative 50 meters long? Doesn't work, does it? One more question. Which one?
I don't know.
None of them? 32. 32, the ratio of male students to female students in a drama club. They love to put these on like the OGT test and stuff. Ratio of male students to female students, drama club at Campbell High is 3 to 4. If the number of male students in the club is 18, what is the number of female students? So there's 18 males. You got to be real careful with this, because a lot of times they'll say, let's see, what did the 3 stand for on this one? Males, and the 4 stood for females. A lot of times they'll say ratio of males to females is 3 to 4, and then they'll give you the total number of students or the total number of people. And you can't set up just a regular thing like that. So let's talk about the class. The ratio of boys to girls in the class right now are what? Boys to girls. 2 to what? That's not right, what'd you say?
Said 3 to 4.
No, boys in our class.
Oh.
Can you count that high?
7 to 1.
7 to 1?
So,
It'd be,
Oh, 2.
it'd be 8 to 2.
Oh, yeah.
Thank you, David, for including me. So 8 to 2, boys to girls, right? Now, if I say that there's 10 people in the class, that's everybody, right? But if I go to set up my proportion, oops, I don't know why I put that 8 there. Put 8, because I was thinking about writing it. 8 to 2, where's that 10 gonna go? Bottom?
Nowhere.
Top?
Yeah, nowhere.
Nowhere, because this is boys and this is girls. It doesn't fit anywhere, does it? Because it's gotta match up. So you gotta be careful when they give you something like that. What you're gonna have to do is say, okay, I want 8 boys, but those boys are out of how many total people? 10. And then where would the 10 go on the other one then? Bottom, and then on top would be number of total boys, which in our case is just 8, right? So here, that doesn't matter because they actually gave us males. What's my first ratio gonna be?
3 over 4.
3 over 4, where's the 18 go?
On top.
And what goes on bottom?
Yeah.
F, X, whatever you wanna use. Cross multiply, what are these called again? First and fourth are called the extremes. So that's 3F. Means 4 times 18 is what? 72? Then what do you do? What's that give you?
72.
This time you actually want to divide because it comes out even. So sometimes you gotta know when to divide and when not to, right? If it's not gonna come. So if you grab your calculator, David, and you punch it in and it comes out 3.33333, then you know you didn't want to divide that time. So what's that 24 tell us?
There's 24,
24
females.
females, 24 girls. Hopefully this one comes out even, right? Because is that going to tell anybody anything if you put 72 over 3 girls? That doesn't mean anything to anybody, does it? All right, again, I'll make that due next time. Would you rather you lose it or I lose it?
Well, it'd be upsetting either way, so.
Questions on the proportions packet?
It's not a
No, just collect it.
Number 10. No.
Number 10.
Yeah, can you show how to do those where they
Why
have,
don't we do
like,
10,
the
11,
number?
13, 14, 15, and 16?
No, I think you should do these.
The more you guys are paying attention, the more of these I'll do. But the more you're talking and not paying attention, then we'll go on. All right, so you have this, you have a binomial in the bottom of this one ratio. What you got to do, and we're going to do a lot of these proportions and ratios for the next week or so, so you got to really know how to do these. Put parentheses around that binomial first thing. Cross multiplies, anybody remember what are, and I probably won't normally draw the bubbles because I'm too lazy. So if you're used to seeing the bubbles, know that I'm just putting a line in there to point at them. What do we call these two? The first and fourth terms were called the what? Extremes. Second and third terms were called the means. Well, in this one, when we multiply the extremes, 6 times 7 is what? Good. On the other side, just write it out this way for now. Please make sure you can tell your difference, or the difference between your B's and your 6s and anything else. What do we do now to start to solve this? Oh, the other thing, I won't collect these today. I'll collect them next class if everybody's helping out and following along. So if that helps you to stay focused a little bit. What's 9?
Minus 9.
Minus 9, good. Now what? 51 over here equals 9b, then what?
Divided by 9 and.
I think I said last time,
And equals negative.
Oh, we don't want decimals.
make sure, right, that's part of it, but make sure you got a calculator. If you have a calculator like Olivia's, I think for a minute. Because when Olivia divided that, divide it again for me, Olivia, I just erased it, I'm sorry. Do you really want to write down a silly answer like that? And you know what's going to happen if you write down a silly answer like that, because all of you are fairly intelligent? I'm probably going to take points off, because I don't like that answer. Why don't I like that answer? It's stupid, that's true, but it's just repeating. Why do that? If you see something like that, you guys ought to be intelligent enough to know that when it comes out 0.6, repeating all the way out,
No, you do the little dash above it.
you know, I don't
You
want
just
either
keep
one of
it
those.
a fraction.
You should know that that is a fraction, and it's a certain fraction. Anybody know what 0.6 repeating is? 2/3. 0.3 repeating is 1/3. So when you see that, instead of writing 5.6 with the bar above it or any of that other stuff, you should know to write 5 and 2/3. All right? And the other thing, if you left it as an improper fraction, when you had Mr. Harrison last year, he probably just told you to leave it as a fraction, don't change it to a decimal because it's just silly. The other thing you could do with this calculator, if you see it's going to come out crazy like that, do this, 51, ABC button.
Yeah, I remember you learned how to do that, but I forgot how to do it.
ABC button, had to figure out where it is on that one.
Yeah, see,
And 9,
I can't
and
find
it
the
tells
answers
you
here.
what it is as a mixed number, 5 and 2/3. The other thing you could do, oops, sorry, if you know that 3 goes into both of them, 3 will go into 9 3 times, 3 will go into 51, what, like 17 times? You could just leave it 17/3, and I would accept that answer. That's probably the best answer of all of them.
I don't know where my ABC button is.
Is it TI 83 or 84? It doesn't have a.
How am I supposed to do this? I need to be taught how to use these.
So the only thing you can do on that, and I'm going to tell you once and only once because it's a pain in the butt, and if you remember it, then great. If not, then you just have to figure it out. So what you do, put in 51, well, hit parentheses,
Okay. Oh, do I here?
51
51.
divided by
Divided
9, close the parentheses,
by- okay.
hit the math button, don't hit equals,
Matt, oh, cool.
it says fraction,
Yeah. and then-
hit enter.
Okay, and then enter number.
Yep.
17/3, or like, yeah, okay, cool. I put the little slashes out to the side for my decimal center and have.
So our answer 17/3, or again, was that 5 and 2/3? Either one of those answers would be acceptable. Again, I don't want to see this. I mean, it's the same thing, but once you've done that, or even if you do something like this, you've rounded it off then, which of these answers, this one or one of these two, would be the better answer? These are exact. You haven't rounded anything here. They're exact answers. So whoever looks at them next knows that they have the exact answer. Whoever looks at this next, they don't know if you've rounded it off or what you've done to it. All right?
5.6 with the bar though, isn't
That-
that exact?
That's exact also,
Fine.
but then you're counting on the next person that looks at it, if they need an exact answer, to know that that means the same thing as this, and then they could change it back.
So like my entire paper's saying, hello.
Next question.
Number 16.
Crap, that is a long
It's probably not your entire paper being wrong, because on some of these over here, when they have decimals in it, then what should you give your answer as? A decimal. All right? So if you start with decimals, end with decimals. If you don't start with decimals, end with fractions. Does that make sense?
Yeah, it actually does.
You said 16? Somebody say 16? Is that? Problem 16, this might help too. I don't think I did any of them on the test, but if you do the test redo and you do the bonus, this is one. There's a few of these on here, and oops, I already put the parentheses around it. So if you have a binomial, remember that. These are the ones that on the bonus on the chapter 5 test, you got a factor, and that's what this is. Cross multiply here, I'm just going to write that down, 3x minus 1 times x plus 2. Do our means, 2 times negative 2 is negative 4. Now when we have something like this, the thing that makes most of you upset about a problem like this is when you're finished, you want it to look like this. Well, the bad thing is, what number needs to be over here? 0. You need to have a 0 on that side. Well, to do that, we got to undo all of this on the left-hand side, move that negative 4 over to the left-hand side to get 0 over there, then redo all of it into those parentheses. All right? And the way we do that, first thing we do, FOIL. First terms, 3x times x gives you what? 3x squared. Outer terms, 3x times 2 gives you what? Does everybody remember FOIL? 6x. Inner terms, negative 1 times x gives you what? And then last terms, negative 1 times 2 gives you what? Now, what I normally do, if I multiply this out, I know I need to move that negative 4 over. When you jump that equal sign with that negative 4, what's it going to become? Anytime you move something from one side of the equal sign to the other side, what happens to it? It turns to the opposite. So that negative 4, when it jumps over here, is going to become a what? So I just write that and put, just put that there. All right? Does that make sense? To make it a step shorter, all I did was I went ahead and moved that negative 4 over to here before I started collecting like terms or anything else, just to make it a little shorter. What like terms do I have?
4 and 2.
Negative 2 and positive 4, what's that give you?
2.
Positive 2. What other like terms?
6.
That's 5x. It's positive. How about the 3x squared? Is it a like term with that one?
No. Learn that last class.
So now we have this polynomial. And what we're going to do is factor it. And the way we factor it, set up our two parentheses, and you find the factors of the first term. What are the factors of 3x squared? What times what will give you 3x squared? 3x and 1x. Is that it? Yeah, that's it. So this is nice because not a whole lot of choice. All right? We know, Ruth, when you have to make choices, it's when you get in trouble, right?
Yeah.
That's where all teenagers are, right? What goes here? 3x. What goes here? 1x or x. Then you got to find the factors of the third term, which in this case are positive 2. 1 and 2. Now here's where you got to be careful, because if this leading number out here where the 3 is, if that was just a 1 like it was on the E-Day paper, then they're easy. They're not so easy when that leading number out there is anything else. All right? What's the other ones?
-1 and negative.
And you got to make a choice there, and the way you can choose out of those is everything's positive in here, so probably which ones is it?
Positive.
Probably the positives. So now you got to make another choice as to how to stick them in here. So what do you want? +1, +2, or do you want to switch them around, put +2, then +1? And it does make a difference.
+2.
Does everybody agree with Sharice?
For now.
Now, what we do, once we have it that way, just because Sharice said it, we say, that's gotta be right then, right?
I don't know, I feel like it should be.
Is that the case?
right, but it-
That's how it turned out.
Now you gotta check it, and the way you check it is you do FOIL again, except all you do, outer and inner.
Is oi.
Just do the, right. So we do the outer, what's 3x times 1? 3x. What's 2 times x? What's 3x plus 2x? Is that what we had in the middle right there? So that means we did it right, we got it factored right. Good thing that Sharice told us to turn them around, otherwise it'd been wrong, and we'd had to go back and try again.
Well, no, I'll wait till we're done.
Are we completely finished?
No.
Now what you gotta do, if I'm multiplying two things together, I got this black marker and this purple marker, and I tell you, when you multiply them together, you get 0. What's that tell you? They're both 0? One of them has to be 0, right? And that's what you're saying here. Either this one is 0 or that's 0. So your first equation, either 3x plus 2 equals 0 or x plus 1. This is another thing that gets a lot of you, because usually when you're solving for x, you're used to getting how many answers? 1. When you're doing polynomials, quadratics, how many answers are you going to get? 2. How do I solve this one? Solve it. It's easy. Subtract 1 on each side. What's x equal? That's one of our answers. How do I solve this one? Minus 2, you get 3x equals negative 2, then what? What's x equal? Negative 2 over 3. Just leave it that way, right? Don't mess with it. Don't grab for your calculator. Now, on like the geometry stuff, you probably need to go back and check, because a lot of times those negatives won't work. If we're dealing with an angle or something and you plug it in, and that's going to make the angle come out to be negative 50, can you have an angle that's negative 50? No. So you might have to check, make sure. But on this paper, or on these, those are your two answers.
On that paper in your hand, does it tell you all the answers?
No.
Oh, well, because I was gonna ask if 13 is negative 3 over 14. Did anyone get that?
Wait, for what?
13, negative 3 over 14.
I was negative. Yeah, I did, yeah.
Could we work out?
13?
I don't want to make you work it out because it's like a lot like the other one.
That's all right.
Well, can I ask you for distributing? It's 6, like 6 on the outside, and then parentheses 7 in. Would you take 6 times 7?
Yep.
Okay, so then it would be 42 in.
Yep.
I feel like that was a big number. It came out weird.
So you got that right? When you cross multiply, 42 in plus 6 times 9 is what?
54. And then I minus 54. And I got negative 9 equals 42 in. And then I got, for my answer, negative 3.
Now, on your calculator, when you do this, if you do that, like I told you a few minutes ago, it'll reduce it down for you.
Well, that's what I did, and it gave me, okay, that just seemed like a weird number, and I thought it was weird how my answer, like, ended up being the negative 9, and then I had to divide it by 42, that just seems weird.
And if I take Olivia's calculator again and do that, 9, ABC button, 42, it'll reduce it for you. You guys know that?
Yeah, I knew that
That
when
the
I-
calculators will reduce it.
Okay, now I.
Other questions?
We do 28. I did it, but I was gonna say I knew what I was doing.
28, the Big Town football team outscored its opponents 5-2 last season. So what's that tell us? For every what? 5 points they scored, their opponent scored 2. If their opponent scored 38 points, how many did the Big Town team score? Now, this one, and I sort of lied to you because I told you every time you see something like this to do what? Put what with each of those numbers? An X. This one, it's not better to do it that way. All right? Most of them it will be. I can't tell you every problem. Okay, this one, this kind of problem, it's better to do it this way. This kind, it's better to do it that way. So I just sort of lied to you and said, hey, anytime you see this, do it this way. So what we're actually going to do here is set up a proportion. What's our first ratio that they tell us? 5 to 2. Now what you got to make sure is that you know what each of those numbers stand for. The 5 stands for which team?
Big Town football team.
And the 2 stands for? So I'm going to put a B and an O there to remind me. Where's that 38 going to go then?
The bottom.
And you got to make sure you match them up. Since this was opponents over here, it's got the opponents on the bottom over here. What are you going to put on top? X. And this is something I don't like that every teacher in the past has taught you. I would not put an X in there. Why not?
Confusing.
Put a B or something like that in there. Something that tells you. What's that B stand for?
Big Town.
Big Town points. Right? That way you remember when you get down here to the bottom, hey, I know what this is. So if you use a letter that makes sense for the problem, it'll make more sense all the way through. Even when Ariel gets distracted every couple of minutes, right? You get distracted and you never do that. We cross multiply. What's 5 times 38? Somebody help me out. 190?
Yeah. I did mine differently in this, but I got the same answer. I don't know, I kind of did it the same way, like, if I shouldn't set it up, I just kind of did it in my head, but I kind of did it the same way, I don't know.
Then you do what? Divide by 2, what's B equal? What did B stand for? Points the Big Town team scored.
Can you just put 95?
95 points, yeah.
Can you do number 30?
30.
That's small
Certain desert environment, there are a lot of small rodents. There also happen to be a lot of snakes that feed off on those rodents. The ratio of rodents. This is why I'm a math teacher. The ratio of rodents to rodent-eating snakes is 13 to 3. If there are 4,000 snakes in the area, about how many rodents are there? So they give us this 13 to 3, and we know that there's 4,000 snakes. Set up a proportion. What's our first ratio going to be?
13.
Now you got to be careful when you go back and read this. What does 13 stand for? Those are rodents, and then the 3 is snakes. So where am I going to put that 4,000? Good.
And then
R for total rodents. Cross multiply. What's 13 times 4,000?
52,000.
3 times R is 3R. Then what?
Divided
What's R equal? 17,000.
That's what I got.
Well,
Now this one's a real life one, so do we really want to, here I'm yelling at you for writing stupid decimals down. Do we really want a decimal on this one at all? No. Are you going to have a third of a rodent? No. All right, I'll bring one in and show it to you, a third of a rodent next time, all right, Olivia? You probably enjoy seeing it.
My owl carcass thing we did in 4th grade in zoo, it was like, what is
You said 17,333, right? Is that right?
Okay, for these, since like the lines are kind of small, can we just circle our answers?
Yeah. And you probably noticed down there too, what did they say when they asked you the question? About.
Yeah.
It's not gonna be an exact answer. Do we know for sure that there's exactly 17,333 little mice running around out there? No.
Can you remember 24 and 25?
25?
Yeah.
You said 25, right?
Except for
Which one?
24 and 25.
Pick one.
25.
25? 25. The span of the Benjamin Franklin Suspension Bridge in Philadelphia, Pennsylvania is 1,750 feet. A model of the bridge has a span of 42 inches. What is the ratio of the span of the model to the span of the actual bridge? So we want span of the model compared to span of the actual bridge. So we're just going to write a ratio this time. Nothing to solve, just writing a ratio. Well, what's the model? What did they tell us the model was?
42 inches.
What's the actual bridge?
1,750
Feet?
Yes.
Now, what's wrong with that?
They're not the same as.
Not the same units, right? With a lot of the problems we do for the rest of this chapter, them not being the same unit won't make any difference. But since they want just this ratio, we probably need to make them the same units. So which one do we want to do? We want to change 1750 into inches or 42 into feet? Probably 42 into feet. Probably don't want any huge number, right? So 1750 is going to stay the same. About 42 inches. How many feet is that?
3 feet. It's like,
What do you do on your calculator?
you like 42 divided
So do that real quick.
Can you like move your head one inch?
Okay.
Now, you probably don't want to leave it that way either, because you have, even with a half, because you don't want what's called a compound fraction, where you have a fraction in a fraction, and you don't want a decimal in a fraction. So what we need to try to do is somehow either reduce this down or build it up so that there is nothing there. Like if you were going to build it up, you could multiply the top and the bottom by 10, because if you multiply by 10, what happens to that?
It moves the decimal.
Moves the decimal over. So you could write something like 35 over 1750. And that's a little better answer, but what's wrong with that?
It's not times by 10.
It could be, oops, I forgot the bottom one, sorry. Over that, right? Now what's wrong with that? It could be reduced, right? Or if you have, Kate's gonna help us out with her calculator, because on her calculator it'll actually do it. I don't think these other ones will. Try it on your calculator. Hit 3.5, ABC button, then 1750.
It doesn't.
It says error or something, doesn't it? It doesn't like anything bigger than 999 in the denominator on the TI 30s. Now, if she does it on hers, though, I think it'll actually do it.
1 over 500?
So what's the ratio? 1 to 500. So for every foot on the model, how many feet are there on the real bridge? 500. This number right here, if you remember back from the start of the year or earlier in the year, and we're going to cover it again today, it's called the scale factor. All right, so that's the scale factor. For every 1 foot in the model bridge, there's 500 feet in the real bridge. So if you had an I-beam in the real bridge that was 1,000 feet long, how long would it be in the model bridge? 2 feet. Other questions? Probably one more.
24. Yeah, 24 I do need.
Sides of a triangle are 3 inches, 4 inches, and 5 inches. Find the scale factor between the longest and the shortest. So we just want the scale factor, like we were just talking about. You're just comparing longest to the shortest. What is the longest side?
The I is a 5 inches.
What's the shortest?
3.
Will that reduce any? That's your scale factor.
That was really easy.
What we're gonna cover today was scale factor. If I give you these two triangles, and this side's 5, and this side's 3 in this other triangle, they match up. Your scale factor is gonna be 5 compared to 3. Or if you went the other way, could be 3 compared to 5. So scale factor just picks two of the parts and sets a ratio up with them. Sometimes with that scale factor, with this one, we didn't have to, but sometimes you may have to reduce them down. All right, those are going to be due next time, so make sure you finish those. Stuff we do today, sort of real similar to that. The YD day is real, I think just about exactly the same thing as that stuff.
What happens if you can't simplify one?
If you what?